What is hardness? Well, hardness is a reading given from a durometer. The durometer originated from a gentleman named Albert F. Shore in the 1920s. The measurement device was used to determine the hardness for polymers, elastomers, and rubbers by using the durometer device. Albert named all of the hardness scales after himself. For soft plastics and rubbers that Star Thermoplastics produces, we will primarily use the A and D scales. However, the double aught and triple aught will be used occasionally as well. So scales and hardness. How is it that you know what the hardness of things are? Well, you can see in the chart where some common everyday items fall along the scale. I want to point out to you that the scales do overlap. As you can see here, a 95A is equivalent to a 45D. So you understand the scales and how it all began, but how do you measure it and how does it work? Well gosh, I'm glad you asked. Here at Star Thermoplastics, we follow the ASTM D2240 standard testing method for rubber property. The testing is done by placing the durometer onto a sample of material and pressing down to get a reading on the scale. Inside the durometer is where the magic happens. A small spring is used to push a little metal indenter into the surface of the material sample, and it measures how far the indenter penetrates the material. The indenter tips change for each of the scales you will use, and the force varies for each as well, so it's important to familiarize yourself with each before beginning any testing. We are going to show you a typical testing method of thermoplastic elastomers. You can take an instant hardness or a 10-second hardness. You need to place at least 1/4 inch thick material on a smooth surface. If the material is not thick enough, it can be doubled or tripled. The material is placed on the countertop, and then the durometer takes the reading. The small red pin indicates the instant hardness. For the 10-second hardness, we hold the durometer down for 10 seconds and take our reading. This gives us a hardness of 74 and a 10-second hardness of 70. Hardness is typically measured per batch. Occasionally, you will find QC needs to be done on every box. These instructions can be found in the Special Instructions section of your paperwork. Now that you've seen a demonstration, it is important to explain our expectations for you to record all of your data. Each line has a lab book, and you are responsible for recording all of the data from your work, as well as your name, the line you're working on, the product code and name, the lot number, batch number, box number, and again, all of your data and work from calculations. Let's test it again while paying extra attention to the setup. Before we begin testing, we want to make sure we have all of the items needed for the test. We have our calibrated durometer. Here are our molded plaques that have fully cooled of the material we just ran and will be testing. We need 10 plaques total divided into 5 sets of 2 plaques each. And of course, our calculator, pen, notebook, and quality control documents. Before we continue, I do want to point out that you will need a relatively clean workspace. For our quality control process, we take several readings and get an average for the batch. We will take the first set of plaques. As you can see, we have 2 plaques stacked on top of one another to meet the minimum thickness required of 1/4 inch. Due to variations during molding, we take a 10-second hardness reading with a handheld durometer at 3 points on the plaque, the left, center, and right sides. Once all 3 readings have been taken, we will take the average for that plaque set. We will repeat this for the remaining 4 plaque sets and again take the average for each. Once we have all 5 averaged, we will take those and average the group. This will give us an average for the batch. Now that we have covered how to test the hardness of a given sample, you will need to record it as part of the quality control process. There are 3 documents that you will need to be aware of. These can be found in your production folder paperwork. First, the quality control chart. This is the sheet where you will record the hardness for each of the batches. Place the batch number on the top column and place the calculated average batch hardness value in the column closest to the value in the far left column. A few things to note are the range indicators along the right column. The USL and the LSL mean upper and lower spec limits. The UCL and the LCL are the upper and lower control limits. You want your data to fall inside these limits. If you fall outside these limits, you will want to start over with a new sample from the batch. The target, this is the ideal hardness. You will need to record the data from each batch on the pellet quality and packaging control sheet. find the corresponding column for the batch number you have data for and record the value in the corresponding box. The last sheet is also one of the most important. This is the Certificate of Analysis, or the C of A. It is the average of all the data from all of the batches. The C of A is sent to our customers with each order as verification of our quality. Referring to one of the previous 2 quality control sheets, you want to take the average of recorded batch hardnesses and place the average hardness on the C of A line. An average is calculated by adding up all of the values and dividing by the quantity of values you have. We will take these 5 averages and divide by 5 to get our average hardness of 69. A few tips we want to share with you to help you succeed at getting the most accurate results every time. Tip 1. You want to always use a calibrated durometer with the correct scale. Tip 2. Use only fully cooled plaques. Not using cooled plaques is like taking the hardness of ice in liquid form instead of its solid form. You will get a very different reading. Tip 3. Measure hardness after specific gravity to allow enough time for plaques to cool. Tip 4. Review the special instructions section of your paperwork to determine if QC testing is needed per batch or per box. Tip 5. Be as accurate as possible. Incorrect data can result in returned material, machine issues, and even the loss of a customer. We strive each day to service our customers.